Good evening, everybody, and welcome to this slightly unusual ORF monthly meeting because it's a joint initiative between Stromness Museum and ORF. And it was an idea brought to us by Jeanette. Thank you, Jeanette, for coming up with this idea to ask Mark to come and talk to us today about this work that's going on in her patch as the local councillor. So we thought it was a really good opportunity to do two things. One, to get some footfall to go and see the Powered by People exhibition down at the museum, which I think is simply excellent. And secondly, to splice that into the monthly ORF meeting. If you're not a member of either ORF or the museum, you're welcome to join either and or both. So please do feel free. We do make a notional charge for people who are not a member of either, but we won't fight you to the ground to wrestle money off you. Leave it to your own complexes to cough up some money if you feel like it. Tonight we're really grateful to Mark to come and talk to us today from Subsea Micropiles about this really interesting work that's going on, and it's part of the whole story of the innovation that's continually going on in Orkney. We record the event so that it'll be available on the website later on, because the various recordings are building up into quite a library of useful information, which work on two levels. One, it's information for people now, but secondly, it's information for people later on when people look back and go, how the hell did that happen in Orkney? Why did that work? Just to try and tell some of the story of the innovation and the people who are involved in it. So the next time the Powered by People exhibition is done in another 25 years, there'll be other chapters to write. So the way this works is Mark's going to give a talk. We said it would quite like it to be a discussion and a conversation rather than necessarily being presented at, but we'll see how the format of the day works. We've also there will be a recording. This will be available later on. People are willing to share that and point others to it later on if they feel this is of interest, because this is all about getting information out to people. The idea of the Orkney Renewable Energy Forum has always been to take new ideas, discuss them locally, and find a way that they can be implemented both here and more widely. So we're happy to give both publicity to the whole process, but also give thanks to the fact that this work is happening here in Orkney and is helping to add yet another chapter to the interesting story that is the Orkney's energy history. So, without any further ado, I will hand over to Mark. Mark, you have the floor, please. Do you want to take questions as we go, or at the end? So we go.
If anybody's interested enough to ask questions, feel free. It's better than me projecting for 30 minutes. Thanks very much for inviting me. It's good being back in Orkney. I think we had a really good time here as a company and as a team. And you'll see through the slides here that we had a really positive experience on both Hoy and working with the companies in Stromness and Kirkwall all the way through. A little bit about Subsea Micropiles for anybody that doesn't know. These are the main focus areas for our business. We design, build and install micropile structures as foundations and anchors for various industries. We're just getting going. Orkney played a big part in getting us to this point. I'll go through that in a little bit. To install them subsea, we had to, in the last 3.5 years, we designed, built, tested, and then used a subsea robotic drill, which will take us, as we scale up, it'll take us, I think we can go up to about 300 metres water depth right now, but all the components are ROV components, so they're rated to about 3,000 metres. Because we are still pretty young and pennies are important, we only bought 300 metres of umbilical. So if we go deeper, we need a longer umbilical. We're working through an industrialised solution for high volume installation. So really that is aimed at solving the problems that are going to come with floating wind when that starts arriving. Hopefully next year in demo sizes. We have a technology that we acquired the IP for called acoustic zoom technology, which allows us to measure the seabed as we're drilling to install the micropiles, which nobody else can do. And it allows us to do things like we did in Scapa Flow, which I'll go into. But it's really exciting for us because it means that we can really significantly reduce the cost, the upfront capex cost of getting seabed data, which nobody ever really gets a return for that investment that's upfront. So we can really help these wind farms reduce that. And because we can do this bit, a lot of the technology here lends itself very well to life of field condition monitoring. We won't go into that today much, but you will start to see why in the slide. That is a bit further out. We need to start installing some wind farms first. A little bit about me. I don't know many of the people in the room. This was the hardest slide to put together today. I think everybody hates doing this. I call myself an ex-master mariner. I don't know if you're ever an ex-master mariner. I don't feel like I've ever stopped being one. But I came on shore in 2002, I think it was, to work with Action Group. And I was with them for 10 years in Aberdeen and Houston, delivering projects globally, large oil and gas projects in the main. And I ended up, for some reason, being slowly pushed into business development, which I swore I never was, and ended up quite enjoying it. So you can see through my various bits of my career, I've kind of switched back and forward between operations and commercial, which is a strange mix, actually. But when in my experience, when I've been selling large complex projects with oil clients predominantly over the years, you have to take the client on a journey, and it's normally a multi-year journey to get to a contract. And through that, you have to be able to help solve problems with them. And so the operational experience is really handy. And being able to sit with a project manager in an oil company and talk about the problems that he doesn't know is going to happen yet really helps. So I've found it quite easy to switch between the two. And then just a little bit about installation experience. Being a captain on Maersk offshore vessels, I installed for years many drag embedment anchors all over the world. Lots of driven piles and suction piles. One micropile anchor, which is what we're here to talk about. So the first one installed subsea was the one we did in Scapa Flow. Just to give everybody a little bit of context around the background, micropiles started off in the 50s in Italy. Fernando Laisi, an Italian engineer, was tasked with trying to save old monuments in post-war Italy where there was no money and a very tight area in built-up areas. So the traditional ways of stabilizing the soil beneath these monuments just wasn't an option. And he looked at the root pile structures and trees for inspiration, and eventually did this, where he replicated it. And as it grew and grew and grew, by over the next 20, 30 years, it became the dominant foundation onshore. And what Subsea Micropiles are doing is adapting that same technology, very proven, and applying it to offshore subsea. It started 2008. Our CEO and founder, Derek Robertson, was working with Lockheed Martin. They were putting a huge amount of money into renewables at the time. They wanted to build these water conversion, energy conversion units that were like big oil rigs. And they were in deep water offshore Hawaii, where there's volcanic seabed. So deep water, very hard seabed, really difficult to anchor anything in. And John Machin, who is a renowned geotechnical engineer that I worked with at Actian, got together with Derek and said, well, why don't we use a cluster of micropiles, the same as they do onshore in civil construction, and just install them instead? And of course, the first question is, how on earth are we going to do that at 2,000 meters water depth? But at the same time, there was this whole revolution happening in subsea robotics, where the tools that would be needed to do it were actually already coming to the market. They were being used for geotechnical drilling, soil sampling. And so when we started out in 2017, when Subsea Micropiles was established, the idea was that we were going to use one of these existing tools. But as the renewables market started to pick up pace, it became unfeasible to use them. If they were going to be available, which they're really not, they would be very expensive. So I came on board in 2022 as employee number 2. And we very quickly decided that we would design and build our own drill, which was quite ambitious for a little company with no money. We found a way. We got some grant money through Ireland, Enterprise Ireland, and kept going. And then this year was the final results of that, of installing offshore Scapa flow. 24, we made a lot of progress. We acquired the IP from Acoustic Zoom, and we really started to make the plans. That's the first time I had ever been to Orkney. I came over last July, met Gareth, met Alex, met Liske Marine, and just found it amazing. The attitude here was something that you don't really see in the mainland much. It was definitely can-do, positive, warm and welcoming. Oh, you've got something exciting to do. We can definitely help you. And so we decided to do our prototype test here. Then Orkney Harbour actually got on board very quickly and said they need an anchor. So we combined the two, and it helps us get to technology readiness level 8 if we install a commercial anchor. So we agreed commercial terms with Orkney Harbour. So when we installed it, we sold it to them, which helps us, helps them. And now they've got a working anchor in Scapa flow that they can use. And now we've finished the project. We are now looking at optimizing designs and starting to scale up a bit and look at the next things down the road. I've got an animation next that just gives you a cartoon of how it works, how it all goes together. This was the anchor that we installed in Scapa. About 8.5 tons, triangular steel anchor with a pile sleeve on each corner. So we put it on the seabed and then lower our drill down on top of it, which is the same shape. We use a percussive hammer drill because we want to take advantage of really quick drilling penetration through rock. And what that means is we pump high pressure seawater down the middle of the pile, which fires the percussive hammer, which allows us to drill and make good progress. Then we flush the annulus with the same seawater. We make the connections on the seabed with the clamp system on the drill. So we work in 6-meter pile lengths. In Scapa, we installed 18 meters, so 3 6-meter piles in each corner. And that's the intended end use is the floating wind farm, or the floating wind foundations. So it's interesting the journey that we've been on, because the percussive hammers have never been used subsea. They're very well used onshore. Every mine around the world uses percussive hammers to make progress through rock. We have a very good partner in Ireland called Mincon, who is a drilling technology company, and they've supported us all the way through this. And they've designed and built percussive hammers to work with water rather than air, which they use. onshore because air is readily available, and these mines tend to be in isolated areas where water's rare. So we went through a whole build, test campaign for about 2 years with the hammer, with two objectives. One was get it to do what we want it to do, but every iteration of design was to get cost out as well, because these are consumable items for us. So it sounds a bit crazy that we'll drill a hole with an expensive drill and we'll leave it all in the hole and grout it and cement it in. But when you're doing this on volume, so some of these wind farms, floating wind farms, are going to need about 1,000 of these anchors. So the amount of time it takes to recover on a vessel that costs 150 grand a day is outweighed by, let's just leave it in the hole and save the time. So it's all about efficiencies at large volume. And this was the prototype. This was we've installed a couple of these onshore to do load tests, but this was the prototype for offshore.
Sorry, could I ask a question? I noticed on your video, you sort of a diversion of the stuff that was coming back up the pipe into the base of the anchor.
Yeah.
Is that just to try and reduce the amount of pollution caused by the chips that come out, or what's that about?
Yeah, so you'll always end up, when you're drilling, you'll always end up with some chips that come up the annulus.
Yeah.
But most of them will go through that pipe into the middle of the anchor.
Right.
And the idea is that the way we look at it, environmental footprint is how much impact do we make on the seabed? And we try to keep the impact within the footprint of the template.
So you that stuff that you've drilled out just gets left in the anchor.
Yeah, it's just extra ballast.
Yeah.
And then when we cement, the cement ends up in the same place, so it goes higher than top.
Yeah. Right. Okay, that's fine. I kind of thought that, but I wasn't sure.
Yeah. No, well, that's certainly the idea.
Mm-hmm.
It doesn't always go exactly to plan, but yeah, if we can minimise how much we take the seabed, then everybody benefits.
Right.
Yeah, so
I don't know if you're going to go on to this, but could you explain the difference and the advantage of a percussive hammer and a
rotary.
three head rotary hammer? Because the last ORF meeting we had the 3-head rotary drill as an example. It would just be interesting to get your perspective on.
Yeah, so we can use those, and in softer soils, those are probably the better solution. Probably. The hammer, like when we set out, we set out to solve what we thought was the biggest challenge and the hardest problem to solve for floating wind, which is hard seabed, maybe like mostly rock, right? And rotary drills will take a long time to drill a hole through rock, whereas we'll drill at 20 plus meters per hour. So even in hard limestone and granite, we're drilling at an 18-meter pylon in an hour. Whereas when we look at the large diameter drilled and grouted piles that oil and gas have installed many times, it can take days or more to do that. So,
sorry, I've got one more question.
No problem. This is better than just me talking.
You've got 3 drills. Presumably, you've got 3 drills. Is that so you can drill all 3 holes simultaneously so as to save time?
So that was my wish.
Right.
Then engineers get involved.
Right.
And so, yeah, the idea was at some point, if we wanted to scale this prototype up into commercial, then we have the option to be able to feed all 3 drills at the same time.
Right.
In reality, that would be a lot to monitor.
Right.
There's one drilling chair with a whole load of screens, and we'd have to change a lot to try and monitor that. And even then, I think we would need to have a lot more automation in the system than manual drilling.
Yeah.
So we're still, even though it's remote, we're still manually drilling. There's still a driller sitting in a driller's chair in a cabin on the deck that looks a bit like an ROV cabin, if anybody knows what those look like. So,
yeah.
So at the moment we cannot, no. We do one at a time.
Following up on that, why don't you just have one drill and rotate it through 120 degrees to drill each of the holes?
that's what we're going to do when we design our next drill. So
Right.
we did this as a prototype to try and be able to install one anchor, the triangular anchor,
Mm-hmm.
in one trip down.
Right.
So if you rotate, you've got to make a choice of whether you feed the seabed from the top with new pipe,
Right. Or drop it down with.
or pick it
canister
all
that's
back up
not-
and then
Oh.
fill it and take it back down again.
But surely you could design something that rotated around with a single drill that held 6 or 8, 10 or 20 pipes, whatever.
It just gets very heavy and
Right.
cumbersome. And the more intricate you want to be, the harder it is. It goes wrong faster, in my experience, subsea. But it's definitely in our mind for the next, because our next, the next size up of anchor is a star shape with 6 piles
Mm-hmm.
to increase the capacity. And the reason it's a star shape is because we can still do it with this drill, and we just turn it and put it back down and do 3 more holes. Beyond that, it becomes a circular template with 9 piles, then 12 piles. And after we get more than 12 piles, you need to be asking yourself, should we just put a driven pile in or a suction pile at that point?
Mm-hmm.
But so we can get very high capacity. So this anchor here in rock, we can, if the rock is competent, we can get 500 ton vertical capacity,
Mm-hmm.
about 300 ton horizontal capacity, depending on the soil, the seabed. But for the bigger templates where they're 6 or 7 meters diameter, there'll be one drill and it'll rotate.
Mm-hmm. Yeah, okay. You might be going to say this later on, but I might still ask you anyway.
Yeah, no, sure.
Once you've grouted them, how do you tension the 3 piles micropiles that you put in?
We don't.
So they're not tensioned.
No, the micropiles it's really just rebar left in place. It's the same as rebar.
Right.
Mark, are you going to cover the noise signature?
We'll touch on it, but not in great detail. Gareth
We'll get to it.
did all of that. Did that answer your question?
Yeah, it answered the question. I just assumed that tensioning it up would make it stronger, especially for horizontal pulls. But you have already said that it's less strength horizontally than vertically anyway.
Well, you're relying on the sheer strength of piles at that point with some grout. Whereas if you're pulling vertically, you're actually relying on skin friction in
Yeah.
rock.
Yeah. And your grout strength is.
And your grout strength, yeah.
No, that's fine. Carry on, sorry.
Okay, no worries. No, I mean, everybody's welcome. I'll just let this play. I think I have to press it twice. This is a video. You might have seen it on LinkedIn, but we made this at the end of the project.
Taken our whole drill system to Orkney and mobilised it in the yard at Lyoness on the island of Wight. From
Can everybody hear that?
It's just playing through your laptop.
You can see behind us now.
You need to get the
It's ready to go subsea.
send the sound
and
to
drill in
the
its
stream.
piles.
I don't have a clue how to do that. That's
That's the only bit of talking anyway, that.
yeah. We tried to get lots of the landscape in as well. So I think with all the work that went into planning this, a lot of time with Alex and Lisa Marine and Gareth, we were actually only drilling for one afternoon. So we installed all 3 piles for the first time ever, subsea, in one session in the afternoon. They took much longer than when we were doing them on shore, when everybody could see everything and touch it. So we were very careful, very slow, deliberate steps. Figured nobody was going to thank us for dropping a pile on the seabed. So I think it took us something like 2 3/4 hours in the first one, about an hour and 45 minutes in the second one, and quicker in the third one as everybody got more confident, more comfortable with it all. There was a few just very basic objectives for the project. We wanted to demonstrate as a company to the industry that we were capable of a full execution in an offshore environment, subsea, which was a big step for our company. I think we start, like I said, 3.5 years ago, I was number 2 employee. We did this project in April, and I think we've grown by 5 more since then, so we're up to about 22 people now. We wanted to reach TRL 8 with a commercially installed anchor. We wanted to collect environmental noise data during drilling, particularly, so that we had a baseline independently verified that we could promote to the industry. And we didn't tell anybody at the time, because we didn't know if we were going to be able to squeeze it in. Gareth will remember some of these conversations, but we wanted to try and squeeze in demonstrating the capabilities of this new acoustic zoom technology that we acquired. And this is where we installed it, right up, not far off the cliffs over here where the deepwater quay is planned. This is my thank you to Orkney, this slide. So a huge thank you to the companies that supported us here. It was a really, I think I started out by saying it was a very, very positive experience. And some of the things that's left a lasting impression with me and the team is, if Orkney can export one thing, it's this positive can-do attitude. I'd love to see more of that on the mainland. I think oil and gas has killed it over the last 30 years, but we found it was so refreshing when I came up here last year, and I left after I was up here for 3 or 4 days, Alex, the first time. And I went home and told Derek, our CEO, we can definitely do it here. There's people who will just figure it out with us, and which is exactly what happened. So it's been fantastic. And I think also it shouldn't be underestimated how the open collaboration between companies was fantastic. Even competing companies were just openly problem solving together with us to help go and deliver this. So it was fantastic. So there you go. Export the attitude and keep being collaborative, because that's actually, I think, the secret for renewables. And it doesn't exist everywhere. So on to Hoy. We had a lot of mixed emotions on Hoy as a team, I think. Nobody has a bad word to say about the experience now. It's probably not a coincidence that come April, when the weather was nice, everyone was a bit happier. When the team arrived in February and their fingers were freezing every morning, they weren't as happy. But we used it as our base of operations. We extensively used Lioness. It's a great asset to have around the Scapa area. But most importantly, I think we demonstrated that this is ready to support bigger projects. The Lioness is ready. Hoy has the space to be ready. There's room for infrastructure improvements if the projects come. So I think that's my takeaway from our experience in Hoy, is that we feel like we helped to demonstrate that Line S is a great location, and it will continue to be a great location to support projects in the future. We just need to help if we can help bring some of those projects, we will. I almost don't want to tell anybody about it because, in case somebody else decides to use it. Some of the challenges, there was lots, time being one of them. We were really hard up against it, working with Crown Estate, Orkney Harbour and the EPS process, but we managed to get that all done ahead of time. Weather, always a risk wherever you go, and you manage it the best you can. And it was no different this time. We decided to try and do it in March, April time, because when we looked at the hindcast data for weather, you could see a significant improvement from March onwards. So we decided to try and do it then. We ended up a bit delayed for various reasons, but we finished it in April. There was some risk associated with the seabed for us. The closest borehole was called Borehole 15 from the campaign that was done by Orkney Harbour a while ago, and it was 60 metres from the location we installed the anchor, which to me as a non-engineer, I'm quite happy. Yep, well, it'll be the same over here, but to a geotechnical engineer, it has no relevance. So we designed to this core sample, which was 60 metres from the location, with the intention of using acoustic zoom to help us figure out how close the actual site was to the borehole. And then, believe it or not, I was telling Alex in the car on the way here, of all the projects I've delivered around the world in some quite challenging places in oil and gas, never before have I been so worried about a red-breasted duck or how to find a bed and food for the team. It was a big challenge on Hoy. We eventually solved it by booking the entire hotel for 3 months and putting accommodation in the car park to supplement it. So we got there, and then it turned out there was no chef, so we had to provide a chef as well. Luckily, my brother is a chef offshore, so he had a network of chefs that we were sending up, time off for a few months. So the guys actually got very well spoiled in the end, but they were this close to living off co-op meal deals. So as always, any project has various risks and challenges, and you work through them, and we had a lot of help along the way. What we did with the survey really astonished us. So we installed something called hydrophone streamers on the seabed. We did that about a week before. Least had a vessel available, so we went and put them all down the week before and put the anchor template down at the same time. We put them in a pattern of 2 chevrons with a circle around the anchor. And we had a hardwired laptop on the barge when we were drilling during all the operations to record and log all the data that was recorded. But this might look a bit like a tie-dye T-shirt to everybody, like it did to me. But what we're seeing here in these red areas is fractures in the rock, about 13 metres down from the seabed. And the most amazing part was our chief scientific officer in the company, Jacques Guigné. He lives in Canada. And I was standing on the cliffs because there was no room on the barge for me, talking to the project manager, James, who you saw in the video. And Jacques called me from Canada and said, "Are you drilling yet, Mark?" I'm like, "No, they've just test fired each of the hammers." So at this point, the hammer is touching the sand, but it's not penetrating. It's just enough to resist so that we can put some water pressure through and test fire it. And Gareth said from the test firing, this is what he could see. So he could see fractures in the seabed 13 meters down before we'd even started drilling. And he's like, I'm looking at the raw data coming in and there's fractures. And I said, okay, great. You know, we'll drill through them. And he said, how much grout have you got? And I thought, oh, that's a point. So we had it gave me some time to think about it. It didn't cause us any problems drilling. So we went ahead, drilled all the holes that afternoon and started thinking about how we're going to grout, because it's obvious if there's cavities and fractures in the rock, we're going to lose, or we have a high risk of losing grout into the formation. So we had a thought about doing that and decided we'll probably have to do it in 2 sessions rather than one single session, because if we start losing grout, we only had 10 tons of grout. We planned to use 6, and I think we pumped 5 down and we weren't filling anything up, and we thought, right, let's stop there, let it set and cure, and then we'll top up, which is what we did. We grouted the first lot the next morning after we drilled, and then we we stopped after about 2 hours, and then we came back a week later and finished it off, topped it off. The other thing that was amazing about this technology was when we were grouting, we're pumping quite a light, it's heavy, but it's very, very viscous liquid down the hose, not at high pressure, but the noise of it travelling through the hose and down the pile and into the seabed, into the rock structures, was enough for our hydrophones to pick up microseismic events in the seabed, which allowed us to track where the grout went. And so all these points are where the microseismic events happened. So we now know that when we were losing grout, where it was going. And it led us to develop a 3D cloud image of exactly where the grout was. And so we were really happy with this. This is a huge step forward in a much quicker time than we had thought about that was possible. It shows us here that we're losing grout into some sort of cavity down here. You would expect to see a lot in the shallow part, but it showed us, it verified for us where it went. And this has quite big implications in the industry, because generally people don't know. You know, you pump grout down and you wait for it to return, and you now know that you've got a full circular return, and you pre-agree how much you're going to return. DNV have some stipulations about that, how much overage. You calculate how much you've pumped, and that's it. You don't know if you've lost any. You don't know if it's gone into any fractures normally. So this is really, really a really big deal for us, and we're continuing to finely tune. I say we. Jacques Guigné is the guy behind this. He's continually fine-tuning this. Yes, so...
Is it in feet rather than metres?
I have no idea.
Well, you said you were only putting 18 metre piles in, and it's over 25 down is the bottom of the grout picture.
Well, that's right, because we were losing it into the fractures, and we didn't know whether those went up, sideways, or down.
Well, that's what I was trying to work out. Has it gone down below?
So it looks like it's gone down here.
Or is it in feet, because you've bought an American system?
Canadian.
Well, no, I just wondered, because it's important to know the difference between feet and metres.
Yeah, I found that's important. Yeah. Yeah, no, I think what you'll find is that we lost grout deeper.
So it wasn't a horizontal fracture that
Some of it
come from a bedding plane.
Yeah, some of it was horizontal, but there was, when you see here, it's definitely gone deeper. So, and I think it was you, Gareth, that when you were on the boat for about 18 hours,
Yeah.
you told us that where you're drilling, there's fractures in this area. And then, of course, we found some.
It was also very close to the fault between the Edy sandstone and Stromness flagstones as well. So it was likely that as you went down, you were going to see something. So that might be a fault. Typically in Orkney is at an angle. You know,
Yep.
so that little shape on this side might be the fault line.
So this is, we will continue to get more and more precise with this the more we do it. Jacques is developing an AI tool for processing. So to give you an idea, we did this in April, and all the post-processing of all the data took us about 3.5 months, 3 months. A year ago, in the March, we did the same thing onshore in Jamestown in Ireland, and it took us 8 months to do all the post-processing. The next time we do it, we will be almost live. So the guy on the barge or the vessel will be able to see this being processed live in front of him. So he'll know what's going on the seabed and under the seabed.
You'll know when to stop and give it a
Yes, he knows like how, well, he
shot.
knows when to ask the question, how much grout have we got? So the outcomes, guys, was the first subsea micropiled anchor installed. We completed our demonstration project. I think one of the things I took away from it, it was really, really positive, apart from all the help we got here, was you can't underestimate how important it is when there's divers in the water multiple times, how that multiplies the risk. And we had multiple diver operations with no issues. So I was really proud of the team. Everybody was calm, everybody was problem solving as a team. Everybody worries in the offshore industry when divers go in the water, quite rightly. And I think everybody was focused on the safety of those divers all the way through. And it was really good to see. And I don't think not everybody really understands how the risks multiply so quickly once you have people in the water. So it made me happy. We sold the anchor to Orkney Harbour, so we can argue that we now have a TRL8 product. We managed to squeeze in acoustic zoom with not much time to spare, and you saw some of the results from that, which is really helpful for us and hopefully for the industry as a whole going forward. And I guess this is more for Orkney Harbour as well as us a bit, but it's now a demonstrated scalable solution that can be applied to offshore floating wet store moorings. So there's at least half a dozen ports around the UK who are very interested in installation of wet store moorings to enable and support floating wind when that comes. So we now have a technology and a product that can be applied to that and minimize the cost of geotechnical studies beforehand. So next, I guess, next for us, everything gets bigger. We've got some pretty significant industry partners supporting us. Mincon, you saw their hammer drill in the water, their percussive hammer. These are a global publicly traded company based in Shannon in Ireland. Fantastic to work with. And they've supported us all the way through and will continue to do so. Halliburton has worked with us for 4 years very closely. And they're our grouting partner. We have a global supply agreement in place with them, as we do with Mincon. And Marubeni Itochu Steel is one of our investors. And we have a global supply agreement in place with them for steel. So when we think about what risks we squarely on as a business, there's lots of business, there's lots of companies that can put something on the seabed. When it comes to high volume putting things on the seabed, the main risks we identified early was access to steel when we needed it, access to cement or grout when we needed it, and access to drilling equipment when we needed it. And we've put a lot of work in over the last 3 years to get these relationships in place with some companies that are big enough, you could argue, shouldn't really even be talking to us, but for some reason they really like the journey. We touched on it earlier about what the next anchors look like, what the bigger capacity anchors look like. These are just some examples of stuff we've designed over the last year or two. This, a 12-pile template here for a TLP, a tension leg platform, so almost all vertical load. So this is designed for a 2,000-ton vertical load. Mm-hmm. These are 1,000-ton, almost horizontal, but some vertical elements to it for floating wind, and this is the same. So this one was our first go at it for a project in France, and it evolved into this. So that's where we're going most of the time now when we're contacted by potential customers. It's for much higher capacities than the one we installed, but it's very scalable. So we're quite happy to have those discussions. And these are the sectors that we work across with all the discussion, all the dialogue that we have. We think aquaculture will be quite interesting. When aquaculture goes into deeper water, which they're all trying to now, I think they're going to find that it's a very uncomfortable place compared to the sheltered areas that aquaculture is used to. And, you know, designing for storm conditions, designing for 100-year storms is a very different thing than designing for something that's in a sheltered location. So we think we can help with that and reduce how many anchors they need. Mm-hmm. We touched on it on the opening slide. We have a working concept for how to industrialize the installation process, where we work with a crane vessel at the front and 3 PSVs behind it. Micropiles are good in a number of ways, but one of them is that it lends itself really well to doing lots of activities in parallel, because we do lots of small things instead of one big thing. So if you look at a suction pile or a driven pile solution, you have a big vessel at the front and it's doing everything because it's one big lift and then one big drill or one big hammer. We can, for us, this big vessel at the front's only a 150-ton crane. And all it does is put tin plates in the seabed in the right place. And then we have 2 vessels drilling all the time. And then the last one would be the Halliburton vessel with it just grouts and surveys. So we have the as-built survey done as it finishes grouting. So we think that, you know, the average installation time for some of these big drilled and grouted piles can be multiple days for each pile. We think that we can install an equivalent capacity anchor in the same hard seabeds at about 4 times that speed with a smaller day rate. And lastly, we are still in dialogue with Orkney Harbour about what, if anything, they want to do next. They have some ambitions to support floating wind and fixed wind in Scapa. There's a lot of sense in it, and but that, along with, you know, Kishorn, Cromarty, Bristol Port, in Murray there is an area where there's a private company leased an area from Crown Estate to put wet store moorings in as a standalone business outside of ports. So we're in dialogue with all of them, but I'm only really highlighting Orkney here. This is where they're planning to put their wet store. at the moment. And that is it.
Thank you.
I've got two questions.
Yes.
You showed us in the museum they have a very good screen. You can actually scroll over the wrecks in the scaffold flow in 3D. What would make your presentation amazing is the same sort of thing with all that data points. You get your mouse and just say, let's look at this route in all 3 dimensions. To me, that would be amazing, just seeing that.
I agree.
And the second thing was, you mentioned that it's quite hard for the guy actually drilling the holes to do 1, let alone 3. If you can capture all this sensor data from all the stuff you're doing, feed that into an AI, it would make their life much easier.
Agreed.
But I'm sure you're doing that.
Yeah, so what we rely on heavily at the moment is a master driller who understands what everything feels like. And we agree, we have to work our way through that, and then beyond that, where, yeah, our next drill will have many more sensors. And we know we're actually working through all the data logs from the data we collected now to figure out how do we improve it and how do we feed that into the next hole that we drill.
That would be a good university project.
Yeah, I agree. We've got, University of Strathclyde, we've got an intern from them just now doing that. Sorry.
Just and linking in with that, one of the initiatives, and actually when Mark came up, first of all, this project was a bit of an inspiration for setting up this idea of a blue robotarium, which some of you may have seen in the paper, which is an initiative which involves a number of the supply chain in Orkney. And it's recognising exactly the conversation we're having here, is that automation and use of AI in the green sector and in particularly in the blue economy is going to be a thing in the future. And Orkney needs to be at the forefront of that, not left behind. So that's why we're...
And it's definitely something you can do remotely as well, isn't it? It's, I mean, there's no disadvantage to being remote.
Yeah. Neil, another question.
I'm still interested in this noise issue. So can you just talk about the relative noise footprint of this versus a rotary pile versus marine traffic noise and all the rest of it? I'm just curious.
It's very difficult to do exactly what you've just asked, because an equivalent size anchor, if it was a single pile drilled in, the noise from the drill is probably more. It would be a much bigger drill with a lot more power. But the vessel that is required is multiples bigger and noisier. Yeah. So it's really difficult to isolate our drill versus their drill versus an impact hammer, because it's everything that goes with it. It's the package that...
I was just thinking in terms of the frequencies that are there, because obviously a percussive, in my mind, has got quite a broad range of frequencies, whereas a rotary drill is probably within a narrower band. So I'm just curious.
So what we've been able to offer out of this first trial is a full spectrum of noise measurements, which gives all of the frequencies that have arisen. And I should acknowledge also XI Engineering, She Engineering from Edinburgh, who worked with us on this. And what that shows is that if you think of that machine, it's like a resonant frame. So whatever the hammering is the main source of the noise, and also some pumping noise. And that noise then gets transmitted through the framework and gets amplified or absorbed depending on where it is. So we haven't been able to do that analysis yet, and it might be a later stage when the next iteration comes along. But there's definitely opportunities for noise attenuation by designing it in the right way. That hadn't been a key focus at the moment. Just to give you a comparison though, the source noise was similar in terms of, the orders of magnitude to other activities in the sea. It meant that the distance at which any noise might be problematic was within a few meters of the actual machine. So it wasn't something that was going to be hundreds of meters away. and therefore it's very different. It's very similar to, ships' propellers and other things that happen. And it was basically, from memory, the source range was about 200 dBA at source, but it tails off
Fast.
fast. Yeah.
Yeah.
So,
One of the reasons Gareth was doing all of this work for us is because we're everyone is interested in the renewables industry, particularly in how to get the noise down in the marine environment, and we're now working on a way that works like noise cancelling headphones. So we're working at noise cancelling. So you hear the noise, and before you hear it, it turns it out and puts it the other way and cancels it out. So that's the route that we're planning to go just now. Rather than try and put bubble curtains and all sorts of extra equipment in that I don't know whether they work or not.
that's good. Other questions? Rob?
I was really interested to hear you talking about Orkney's can-do attitude, because the first time I heard that being mentioned in terms of renewable development in Orkney was at the All Energy Conference in Aberdeen in 2008.
Okay.
When Neil Kermode was asked if Orkney was the right site for EMEC, and he described the can-do attitude there as being one of the reasons to be here, and the fact that that's not been dulled our 17 years of challenges. That you have obviously identified a lot of the plus points about Orkney and then some of the challenges that you face, but is there any one thing that needs extra investment or resource to allow Orkney to be part of this commercial sort of step change that we want to see here?
I think accommodation would be good.
Shame.
Banning cruise ships. No. I think what we found was like accommodation was one thing, but at the end of the day, we had a plan B of putting a mobile camp in Lioness if we had to. So, we laugh about it now, but there was always a way to accommodate the team, really.
Yeah. Well,
sorry.
you've had 2 world wars where they have accommodated as many as can.
Yeah.
And that's 100 years of experience.
I totally agree. Probably the single biggest thing that could use some investment for bigger projects is, because it's definitely a bottleneck that has to be managed, even for us, was logistics. Now, there's only so much you can do because it is a bunch of islands and it's going to stay a bunch of islands. So, I mean, when we are bringing big equipment, that causes problems. It causes ferry problems. And if you're not careful, you get caught out. And I'm sure we did get caught out a few times, and we won't be the last people that get caught out. But, if there's ways around it, which everybody will find there's ways to use the marine infrastructure that's here.
We've got a professor of logistics started now, so
okay,
hopefully that will be solved.
Fantastic.
I think this, just also to build on that, is one of the reasons that we put the Robotarian plan in place is that we know that we have a great spread of equipment and assets already and people, but we know we need more. And if each of us try and cherry pick the next thing that we get, it's just going to happen piecemeal. By coming together in a more strategic way, we can maybe make a strategic ask. So, there is enabling things like barges, like anchoring systems, actually having a strategic array of anchors that are put in the right place for maybe the interim innovation stages that are going to happen over the next while is something that could be done.
Yep.
Having, the team were able to make use of the kit we had, but we didn't have all the kit they needed. There was stuff that had to be bought. So some of the kit that got bought probably is still here and could be used in the future. But, it's that magpie attitude as well of acquiring things. And I think the other thing that Mark mentioned is collaboration.
Yep.
And there's 2 things that work for collaboration. One is, an evening like tonight where you just get together and you talk and you listen. But there are times when having a bit of resource, basically money, to allow collaboration to take place, to give people time to get off the hamster wheel and go and think about things. I think that's something that would be good. And it might mean it's collaboration with companies that are off the island. You know, if you could get some support to go and collaborate as part of the preparation. So it was brilliant that their team was so committed to Orkney to come up here, but not everybody would have the same attitude. So
That's right.
we might need to be able to get off the island as well.
Yeah, and that I mean, being able to support that would support growth of small companies on Orkney. It certainly helps with visibility, which helps growth.
Yeah.
And it'll take some investment.
Yeah. There's a question.
I just wanted to ask about effectively having single-use drills. What's the environmental impact of that? Have you? I know it's obviously a cost implication, but have you considered, you know, effectively something that's single-use? How many, you know, going to be making production for something that's going to be left and not used again? Is that something you think about?
We think about. Myself and Derek particularly are fairly sad individuals. These are the discussions we have on a daily basis. So one of that, because we don't want to be a company that throws away things. That's not our goal. But we have to meet certain standards as well. One of the things that we've started to explore is if we can recycle old drill collars from the oil and gas industry that sit in yards all over the world and will just rot over time and eventually be scrapped. And they're very, very similar dimensionally to what we need. So if we can figure out a way to use, I think we can figure out a way to use them. What we then have to do is figure out how to convince DNV that that's acceptable. And so there's quite a slow path to that kind of thing, but there's definitely an avenue. The other thing we didn't talk about here, but one thing we demonstrated on this project was a technology called spiral flush. So in this case, we used it to drill through 3 or 4 meters of sand overburden over the rock, because we have to protect the overburden and not disturb it. So we installed a casing through the overburden using spiral flush technology. But if we just drilled 18 meters with that same casing, then we can recover the pile inside and use that again. So we don't leave the drill in the pile in at that point. So that's another avenue for us to explore. But yeah, we think about that a lot.
So but you're saying you need to have 18 metres of sand to be able to do that?
No, we can do it in rock. We just don't have to for capacity, for structural capacity in rock, because the rock gives you some capacity that sand won't.
Right.
But there is an option to drill the casing size all the way in and recover the drilling rod from inside and use that again in the next one.
And the casing's strong enough to take the weight, is that what you're saying?
Yeah.
Right, okay.
I think just going back to the lady's comment about the environmental side, the other thing which normal anchoring has is quite a big seabed footprint, because an embedment anchor gets pulled into the mud or the sand. And so that happens over a distance of maybe 10 metres, 20 metres as the anchor is pulled in, and then you've got the chain lying on the seabed. So there's abrasion of the seabed from that. So this anchoring system should have a smaller footprint than that kind of approach.
Well, if you think about permanent anchor and mooring systems, so permanent facilities in oil and gas have to do this. Floating offshore wind don't need temporary anchors, they need permanent anchors and moorings that comply with the same rules. And a drag embedment anchor can only be a permanent anchor if it's been proof loaded in situ. And the proof loading will take 800 tons of tension, which means you've got 3 boats lined up and you're connected to each other, big vessels. So you're adding operational risk on operational risk. And in my experience with all those drag anchors that I've installed, at least 20% of them fail and have to be installed again. So you're literally digging up the seabed. Now in oil and gas, it was kind of acceptable because you're only doing it 8 times for an oil and gas field, or maybe 12 if it's a big FPSO. but one floating wind farm will need 1,000. So you're now doing this 1,000 times and leaving the chain on the seabed for 25 years. It's just, that's a disaster environmentally. So we don't think that has a place in floating wind. We also don't think it's logistically possible to do, because there's no vessels big enough to handle the chain that's required. I mean, they're now talking about 220 millimeter chain, which I don't know if anybody has been offshore and seen some of the bigger chain, but that's enormous. That's one link of chain will be about that size. So,
but you don't need any chain on with your anchors.
We don't need it. We'll probably have a small chain tail. The difference is a drag embedment anchor can only take horizontal load, which means you have to have chain on the seabed to make sure that that's the case.
Yeah.
We can take horizontal up to vertical loads.
Yeah.
So what we do is pull that allows the developer to design a taut system or a semi-taut system with synthetic rope rather than chain.
Mm-hmm.
And we pull the whole footprint in and reduce the mooring footprint.
I mean, the ones I've seen have go from anchor to a float, to a weight, to the turbine.
That's right.
Martin, do you want, maybe we can have a chat afterwards, because I'm going to get some other people in for questions.
Yeah.
Any other people?
Can I ask a couple of things? One is, well, this is just to clarify something. You're just doing the micropile. You're not doing the mooring system. Someone else has designed a mooring system, and they're supplying you a mooring system and saying,
Yeah.
Can you attach this to your pile?
Yeah. At the moment, the developer will give us loads. So what's the mooring loads and what's the load path, and then we look at the soil profile and design the anchor to.
Do you design it, but do you manufacture this thing, or
Yes.
do you get? So that's not subcontracted to someone else.
No, we're about to sign a long-term lease in Montrose, within the port in Montrose, to manufacture these anchor templates.
Okay.
So we're also in a unique position where we're the only anchor solution that provides a full Scottish content, because every other pile is going to come from China or Singapore for the drag anchors. Nobody builds drag anchors in the UK either. So
that's a good time to stop. And as ever, it's great to have such in-depth questions coming from the floor.
My CFO is going to murder me.
Yes, exactly. I was going to say, as Neil said, these are very informative.
Can we edit
OREF videos expose the industry in all its glory.
Yeah.
So, really appreciate Mark's candidness and capacity there to take us through the story. Obviously, I think it's great for everybody in Orkney to hear the support that you got from everybody here, and I think we look forward to you coming back and doing more work here in the future. So if we can thank Mark again, and thanks everybody for coming.